Hello, in this video we will classify what is considered a polygon. So we are learning geometry, so we're going to classify what is considered a polygon because there are different types of polygons. So first question is, what is a polygon? A polygon is a closed figure, so it says closed, so it has to be closed, in a plane formed by three or more segments. Each segment is connected to exactly two segments, one at each endpoint. Okay. Uh, Segments don't cross each other, so that's also important. Segments do not cross each other, and the segments that have common endpoints are non-collinear. So collinear means they have to be in the same line. So a polygon is convex if no line that contains a side of the polygon contains a point on the interior of the polygon, and a polygon that is not convex is called concave. So what does all these information mean? You'll see when we do an example. So it's really important to know that polygon is a closed figure. So if there's nothing closed, it's not a polygon. And they are all, yeah, the endpoints are non-collinear. And also important is each segment is connected to exactly two segments. And also segments do not cross each other, and the segments that have a common endpoints are non-collinear. Okay, so let's view some pictures. So smallest polygon is a triangle. So we're good in geometry, we're going to learn about different shapes. We're going to talk about parallelograms, squares, triangles, etc. Right? So first, let's start with the bigger picture, polygon. So the smallest polygon is a triangle, right? Because it does have a triangle is technically a closed figure formed by three or more segments. And then in the triangle, each segment is connected exactly to two segments. So here's an example. So yeah, a triangle is technically a polygon. Here's another example of a polygon. See how this is all closed. And yeah, so you could call this polygon, right? So this polygon down here could be expressed as polygon PQRST. Now you have points PQRST. You don't have to call it PQRST. You can call it RQPSTS, right? And as you can see, this is all closed. We have a side, we have points. Segments do not cross each other, right? So I guess this is also considered a polygon, but it's convex. So this is also important. In this image right here, the one in the middle, it's definitely polygon because nothing is open, right? Now, what about the arrows? So as you can see, the arrows never are pointing on the inside. So that's how you know it is a convex polygon. It's closed and the arrows are pointing on the inside. Now, if you look at this image, this is technically a polygon, it's just concave. The reason why it's concave is because the arrow is inside the polygon. So this arrow right here is inside the polygon, and this arrow right here is inside the polygon. So that's how you know if it's concave. So if it's concave, the arrows is pointing inside the polygon, and if it's convex, the arrow is pointing outside. It's never inside, right? So yeah, so here's some of the characteristics of a polygon. Must be closed, right? There can't be any gaps. Only segments, right? Only segments, and it cannot cross. So based on that knowledge, let's do some examples. Here we have this figure, and we got to determine whether the figure is a polygon. If so, determine if it's convex or concave. So, is it closed? Is this figure closed? Yes, there's no gaps, so it's going to be, it's definitely closed. What else? Are we connected by only by segments? Yes, there are only segments only. And does it cross? So we know it's a polygon, but is it a concave or convex? So if you look at the arrows, these arrows are inside. So it's going to be concave. So you could say, yes, it's a polygon. And then you could say it's concave since the arrow is inside. Okay, let's look at image 2. So this looks like some kind of square. So is it a closed figure? Yes, it's a closed figure. It's definitely closed. Uh, do we have only segments? Yes, only segments. So we know it's a polygon now. Is this convex or concave? So let's look at the arrows. None of the arrows are inside, so they're outside. So we know it's convex. So we can say yes, it's a polygon, and it's convex. Okay, let's look at image 3. Oh yeah, that does not look closed. There is a huge gap here, so we can say it's definitely not a polygon. Okay, let's look at image 4. Is this a polygon? Well, it's definitely closed. You only have only segments. So is this concave or concave down? I mean convex or concave up? I mean convex or concave. So you look at the arrows. The arrows are on the outside. None of the arrows are on the inside, so it's definitely convex. So yes, it's a polygon, and it's convex. So what about this image 5? I see a gap right here, so it's not closed, so it's definitely not a polygon. What about 6? Is 6 a polygon? Well, nothing's open. It's definitely closed. We only have segments. But there's one more important thing. See how they can't have intersecting? They can't intersect. So there's an intersection at this point right here. Let's see how this line intersects with this line. So we can say not a polygon because of this intersection, right? What about seven? Well, seven, there's no gaps, so it's definitely closed. Um, is this only by segments? Yes. Now, do you see any intersection? This is not considered intersecting, right? Right. This, no. So this is going to be definitely polygon. And is this convex or concave? We look at the arrows are definitely inside, so it is definitely concave. What about eight? Um, sure, it's definitely closed. There's no gaps, but do we have only segments? No. There's a curve right here that we have to have only line segments, so there's a curve. So this automatically makes it not a polygon. So now we can classify different types of polygons based on the number of the sides. So once it satisfies the conditions of a polygon, right? It has to be closed, uh, only segments, no intersection, no intersecting. Uh, you can describe a polygon based on its size. So if you have three sides, it's a triangle. If you have four sides, it's a quadrilateral. If you have five sides, it's a pentagon. Six sides, you have a hexagon. Seven sides, you have a heptagon. Eight sides, octagon. Nine sides, nonagon. 10 sides, decagon. 12 sides, I can't even say that, dodecahedron. And then, yeah. Okay, so another information about polygon. So a polygon, a polygon is equilateral if all of its sides are congruent. So yeah, a polygon is equilateral if all of its sides are congruent. A polygon is a polygon is equiangular if all of its interior angles are congruent. So I think equiangular just you kind of remember that word comes from geometry. Equiangular means all sides and all angles are the same. So if you have all the angles are the same in that shape, all sides are congruent as well. So this is an example of equiangular. So if you look at this triangle, see how you have all these angles have only one tick mark? That one single tick mark means that their angles are all equal to each other. So if you have all the angles equal to each other, that means all the sides are equal. The same thing with this. I think this is a pentagon. 1, 2, 3, 4. Yeah, pentagon. See how if you look at the interior angles, they all have one little line or one tick mark, right? That means all the sides are the same. So a regular triangle, regular it means equals sides and equal angles. A diagonal of a polygon is a segment connecting to a non-consecutive. So yeah, a diagonal of a polygon is a segment connecting to a non-consecutive. So for example, for each polygon, determine the name, whether it's regular and if it's concave or convex. So here we have this polygon. It has 1, 2, 3, 4, 1, 2, 3, 4, 5. So there's 5 sides. And We know it's 5 sides, so if you have 5 sides, it's definitely a pentagon. What else do we know about this polygon? How should we label this? We can label this pentagon. Pentagon A, B, E, D, E, right? You can start anywhere you like. You just have to make sure, here's, if you start at A, you have to go to B, C, D, and E. And now, is this convex or concave? So if you look at the arrows are outside. So if the arrows are outside, it is definitely convex, right? Okay. Okay, let's look at this image 10. Image 10, this is definitely definitely polygon because um, there's no open sides, right? We have segments, nothing's intersecting. Now, what kind of polygon would this be? There's exactly 1, 2, 3, 4, 5, 6. There's 6 sides. So that means it's going to be a hexagon. So what about this hexagon? You see how how all the angles have one tick mark and all the sides have one tick mark. That means they're all the same. So that means all sides and angles are the same. So it's regular and it's convex. Yeah. Let's move on. Okay, number 11. Looks like some kind of arrow. Is this a polygon? Yes. And how many sides do we have? We have 1, 2, 3, 4, 5. You have a total of 7 sides. So when you have total of 7 sides, you have what's called a heptagon. And unfortunately, none of the angles or the sides are congruent, so it's not going to be regular. And look at the angles inside and the sides. I mean, sorry, is this concave? I mean, concave or convex? So look at the arrows. Oh, you have the arrows on the inside, so that means that it's going to be concave. Okay, let's look at 12. This is definitely a polygon, and there's 4 sides or 4 equal sides. Yeah, all the sides and all the angles are the same. So we know this is going to be a quadrilateral. That means all sides are the same or congruent. So that means we know it's going to be regular because if all sides and all angles are the same, it's regular, or you could call it yeah, equilateral or equal angular. And is this convex? Uh, well, I didn't show the arrows, but the arrow you have one arrow sticking right here. So this arrow right here is not inside, so it's going to be convex, right? So if the arrows are in the inside, it is concave. Let's move on. Okay, let's talk about congruent polygons. So congruent polygons are polygons whose vertices can be made. Congruent polygons are polygons whose vertices can be made to correspond in such a way that corresponding parts of the polygons are congruent. So in order for two polygons to be congruent, they must have the same, their angles must be equal and all their sides must be, so all their angles must be equal and all their sides must be equal. So if you look at if you compare polygon ABCD and polygon EFGH, so this one, if you look at it closely, if you look at angle A and you compare that with angle E, because there's only one tick mark, that means they're congruent. If you look at angle B, it has two tick marks, and compare it with angle F, they have also two tick marks. That means they're congruent. And angle C has three tick marks. Compare that with angle G, they're the same, so they're congruent. And then angle D has four tick marks that compare with angle H, they're the same. And then if you look at the sides, see how this has one tick mark. Line segment AB is connected or related or the same with line segment EF. And also I didn't put this, but there should be another tick marks because the in order to for it to be congruent, all sides and all angles must be the same. So I think yeah, this so let's see, BB. So this tick mark should be related with this, and then there should be another tick mark right here. Yes. So polygon ABCD is congruent with polygon EFGH because all the sides and all the angles are congruent. Theorem, if any quadrilateral, four sides, the sum of it, the interior angle is 360 exterior. So this is also important. In a quadrilateral where you only have four sides, the sum of the interior angle is 360. So that's very helpful. That's going to be very helpful if you want to find like missing angles, right? Here's some kind of four shape polygon, and if you add up all these interior angles, if you add up angle 1, 2, 3, 4, they will add up to 360. Okay, so example 14. Here we have this polygon, and it has four sides, and we got to find angle x. So none of these angles are the same because there's no tick marks, but we could still find angle x because we all know that the interior angle, if you add up angle A, D, C, B, they all add up to 360. So if you add up angle 1, angle 2, angle 3, angle 4, they add up to 360. Uh, oops. I didn't mean, we don't have numbers, we have letters, right? So we have, that's like angle A, B, C, D equals to 360, right? So we can easily find x. So angle A is x, angle B is 87, angle C is 63. Angle D is, what is angle D? 87? Wait, did I miss this stuff? Yes. Angle B is not 87, angle B is 85. Angle C is 63, angle D is 87. And that gives you 360. Here it is. So what would be angle X? It would be 235. Subtract 235, subtract 235. So X is, or angle A is 125 degrees. Okay, let's move on. Move on to 15. So here we have this polygon, we have four sides. That means the sum adds up to 360. So if it was more than four sides, it's not going to be 360, right? They specifically said four sides. So we have four sides. One, two. So what we have to do is, if we need to, in order to find out what angle E is, in order to find out angle F, in order to find, yeah, we got to find, we first got to find X. So you got to add up all the angles and set it up to 360. Okay, so I'm going to kind of calculate terms. 4x plus 3x is 4, 5, 6, 4, 5, 6, 7x. 108 plus 10 plus 67 is 185 equals 360. And then subtract 185. So 175 that's 7. Yeah, 20, x is 25. So now what we could do is find our missing angle. So we could find out what angle E is, which is 4 times 25 plus 10. That is 110 degrees. And then we could find out what angle F is. So that's 3 times x, 75 degrees. Right? Not too bad, right? Okay, was that our last one? No, we have 16 and 17. 18. Oh, let's move on to 16. So here we have this polygon, and we got to find out. I think the direction says find x. So Yeah, we don't have to find the missing angles, just finding x. So we can just add up all the angles. 82 plus 25x minus 2 plus 20x minus 1 plus 25x plus 1 equals 360. Okay, collect like terms, so you can add up this 25x, this 25x, that is 50x. Wait, let's add up all the x's. And then don't forget this 20x. So 25x plus 25x is 50 plus 20, that is 70x. And then collect your constant, 82, -2, -1, constant 1. That should give you 80. And set up to 360, and then subtract 80. So 360 minus 80 is 280. Divide this by 70. And you get 280 divided by 70 is, so x is equal to 4. Okay. Let's do 17. So in 17, 1, 2, there's still 4 sides. Uh, it's definitely quadrilateral, and the direction says find y. So on this one, we got to find this angle here. Actually, we could find both, find y and x, right? Well, how do we do this? Well, if you look on inside here, you know that if you add up all the angles, it adds up to 360. So it's 80 plus 115 plus 100 plus y equals to 360, right? Go ahead and add them up. That is 295 plus y equals to 360. Subtract 295. You get y equals to 360 minus 295 is 65. Now let's find x. So we know how can we find x? Well, I know this is a straight line. And what does straight lines always add up to? 180, right? So it's y plus x equal 180. We can replace we just found y, which is 65. So y is going to be 65 plus x equals 180. Subtract 65. We get x equals 180 minus 65 is 115. Okay, let's do one last one. So on this one, this one is a little bit strange, right? Inside right here, we know that it adds up to 360. Now, can we assume that these two lines are parallel? No, no, we cannot assume that this line right here is parallel with this line. Although it does look very parallel, these are not parallel because they don't say it's parallel. They don't say it's parallel, or you don't have this mark right here. right? So you could say these lines. So we can't do the alternate interior, alternate exterior, right? So we can say these lines are not parallel. So we can't use alternate interior. You can't use alternate interiors, vertical, corresponding, all that. So what we know is we definitely, so if you look in the inside, we do know it is a quadrilateral. So if you want to redraw the inside, it would look something like this. So this is single W, this is single Z, this is Y, and this is 75 degrees, right? What else do we know? I see a straight line, right? I see some straight lines. Oh, I forgot. Sorry. This was also given right here. This was given 80 degrees. So that was going to be helpful. So if this is going to be 80 degrees, um, what else could we say? So if you look right here, Z, right? And if you continue putting a straight line, uh, I think this is going to be 60 degrees. Because if you compare this, the Y and the 80, 80, 60. Okay, actually, I think we can use, I believe we can use vertical angles. So 80 degree is vertical with angle Y. So we could say Y is 80 degrees. Okay. So that means Z, this Z plus, so Y is 80 because of vertical angles. Can we figure out anything else? Yes, we can say W plus X is 180. And here's X right here. So W, we can say that if because this was given, that means Y is going to be 80 because vertical angles. And that means we have two equations. We could say that W plus X is 180. And we can also say that Z plus 60 degrees is also 180 degrees because it forms a straight line, right? Um, Do we know what W is? I think it would be, so I think that angle 75 plus W is going to add up to 180, right? 180. Wait, so we know that W plus X equals 180, and then Z plus 60 is 180 as well. So right here, we could solve for Z. So if I subtract 60 from both sides, that means Z equals 120 degrees. And what else do we know? If Z is now going to be 120, can we figure out what W is? Because if I find out what W is, I could figure out what X is, right? Mm, I think W will be 85. Yes, I think W is going to be 85. So W, if you add up W plus X is 100, it's going to be a straight line, so that's going to equal to 180. And why do I say W is 85 degrees? How did I know that X, not X, but W is 85 degrees? Oh, I know. I know that Z plus W is going to be 180, right? Wait, I know that Z plus 60, so I know that Z is 120. So I think what I did was to find W, all I did was I think I subtracted 180. Yeah, I know that W is going to be 85. Yeah, for some reason I know that W is going to be 85, and I know that I don't know what X is. So I can solve for X by subtracting 85. So I get X equals 180 minus 85, which is 95. So X is 95. Oh, now I know how I think I know how I got that. Uh, so what you could do is, oops, we know that the interior in this polygon adds up to 360, right? So we say that if you add up angle, all four angles, right? W, 25, Y, Z, they all add up to 360. So let's do that. 75 plus 80 plus 120 plus W is equal to 360. So when you do the work, you get W equals 85. Oh, that's how I got that. Okay. That's how I got W. And then I could solve for X now. And that's how I got X is 95. Okay. I guess we could stop here. That's the introduction to polygons or geometry.